So it says that in an equilibrium mixture of hydrogen, iodine, and HI gases at 698 Kelvin is determined to have a consistence of 3.5 times 10 to the negative third moles per liter of hydrogen, 1.250 times 10 to the negative third moles per liter of iodine, and 15.59 times 10 to the third moles per liter of HI. What is the equilibrium constant for the system at this temperature? So the first thing we need to do is we need to come up with an equation. So our equation here, we have hydrogen and iodine, and they're going to react together. And they're going to react together to make our HI. Our next step is going to be to balance this. If we balance this, do I have to do anything?
A 2 in front of the HI.
Perfect. So we're going to put a 2 in front of the HI. And now we have a balanced equation. I'm actually going to change this just because this isn't right, because it's an equilibrium, which means that we have it going in both directions. So it's going in both directions. So some of the reactants are reacting together to make our product. Our product is decomposing to make our two reactants. So at equilibrium, those are happening at the same time. Now we have to come up with our equilibrium constant. So our KEQ. You guys tell me what I need to put on the top.
The product.
The product. So we have our concentration of HI goes on top. Do I have to do anything else to my concentration of HI?
To square it.
Perfect. We have to square it because there's a 2. So the coefficient in front of our HI tells us the exponent that we have to put on the concentration. And then on the bottom, what goes on the bottom?
Reactants.
The reactants. So we put our concentration of hydrogen times our concentration of iodine. So we have our two concentrations. Now all we need to do is plug in our values. So we take our values from the problem. So it tells us that in the problem, it's 15.59 times 10 to the negative third moles per liter of HI. So that goes on the top. So we have 15.59 times 10 to the negative third. And this is squared. So we have to square this value. And then on the bottom, we have to put our two concentrations of hydrogen and iodine. So our concentration of hydrogen is 3.560 times 10 to the negative third, multiplied by our concentration of iodine, which is 1.250 times 10 to the negative third. Now when we put this in our calculator, so I did see a few people making calculator errors. So just because there was a lot of that, we're going to do it together. So we do 15.59 times 10 to the negative third squared. What do we get? Did anybody get that one? Perfect. Awesome. And then if we do the bottom, so we do 3.560 times 10 to the negative third multiply by the 1.25 times 10 to the negative third. What do we get? Hopefully you guys got perfect. That's perfect. 4.45 times 10 to the negative 6. All right. So now if we do that that division here, when we divide those two things, we should get 54.6176. But then we have to look at our significant figures. So we got to look at our three different pieces of information that we use to get our equation and our answers. So we have here, how many sig figs do we have?
Four.
Perfect. How many sig figs do we have here? Careful, I'm sorry, I'm covered it up. So we have 1, 2, 3, 4. And how many sig figs do we have here?
Four.
Perfect. So we have 4 in each of them. So we have to round to 4 sig figs in our answer. So our answer should be in 4 sig figs, which stops here. Do we round up or does it stay the same?
Stays the same.
Careful. So the 7 is what tells us.
Oh.
So
It runs up then.
So it rounds up to 54.62 for our answer here. So that's all we need to do for that first problem. Now, if we take a look at our second problem, it says a reaction between gaseous sulfur dioxide and oxygen gas to produce gaseous sulfur trioxide takes place at 873 Kelvin. At what temperature the concentration of sulfur dioxide is found to be 1.5 moles per liter. The concentration of oxygen is 1.25 moles. That should be moles per liter as well, ladies and gentlemen, or both of you. It should be liters, not Kelvin. Just a typo, I'm sorry. And then the concentration of sulfur trioxide is 3.50 moles per liter. Using a balanced chemical equation, calculate the equilibrium constant for this system. So we have to write a balanced equation again. So sulfur dioxide, which is SO2, and it's gaseous, so we can put gas, plus oxygen gas in equilibrium with sulfur trioxide in gaseous form. So now we have to balance our equation. Is it already balanced? Or is there a way to balance it? Perfect. So we're going to put a 2 in front of our SO2 and a 2 in front of our SO3. Now that we have our balanced equation, we can set up our equilibrium constant. We're going to do that the same way we did the last one. So KEQ And you guys told me last time it was products, so we're going to put our product, which is SO3, and it's going to have that exponent of 2 because we have the coefficient of 2 in front. So we have our products on the top. On the bottom goes our reactants, which is SO2, and that's squared, times our oxygen, which is all alone. Now that we have our equilibrium constant equation, we can plug in our values. So it said that the concentration of SO3 is 3.50. So we have 3.50 squared on the top. On bottom, we have our concentration of sulfur dioxide, which is 1.5. And we need to square that concentration as well. And we need to multiply it by our oxygen's concentration, which is 1.25. So now let's do the same thing. So what is 3.5 squared?
$12.25.
12.25 divided by, so now we have to do 1.5 squared and then multiply it by 1.25.
$2.8125.
Perfect. So now if we do that division, what do we get for our final answer? Oh, perfect. Awesome. So we get 4.355. And then if we look at our problem, if we look at our problem, how many sig figs do we need? How many sig figs do we have for our sulfur dioxide?
2.
How many do we have for our oxygen?
3.
And how many do we have for our sulfur trioxide?
3.
Awesome. So how many sig figs do we need for this reaction? Or for this problem?
2.
2. So if we round to here for 2 sig figs, do we round up or do we stay the same?
Round up.
Round up. So our answer for this one should be 4.4. Do you guys have any questions on this?